energy stored in the spring. Energy stored in the spring means energy in SHM. Energy in SHM, we proved that half kx square potential energy, kinetic energy half m omega square a square minus x square. So that we can prove means what there is k, half k x square. K means what? It's a Spring's constant. Okay, Spring's constant. So first one, in a spring mass system, the spring mass system, spring plus mass means what? Ideal spring and ideal string. Spring is ideal. What do you mean by ideal spring? Ideal means what? It's a massless spring. Okay, so first if you talk about this, what is this spring? I'm talking about this spring. Okay, spring is what? Ideal. It's a ideal spring. Ideal spring means ideal spring, it's a massless. Okay, massless. Massless spring. Massless spring means what? Whose mass is very small. Mass is very small, very small as compared with mass means was suspended body. Suspended mass. Okay, so when you are talking about this ideal spring, in ideal spring massless means what? Whose mass is very small, means here the force is constant. Force in the spring, force in the spring is constant. Everywhere it is constant. Which force is this? This force is called restoring force. Is a restoring force. Okay, spring mass system, just a spring is what? Like ideal spring we talk on this one. It's called what is it? It's a restoring force. So restoring force is what? F. F is proportional to minus x. F is proportional to minus x. It means F is equals to minus kx. My first question is about, so where do you get the restoring force in the spring? When a spring linearly means what? Along with a straight line, a small compression, small elongation. If you go for the small compression, just if it is compressed, otherwise elongated. Okay, here is the spring, natural length of the spring. Okay, so this is what fixed here. Now next one, here there the possibilities are, it's a elongated by a external force. By external force. So this is again, the spring is compressed by external force. Something force in the spring which opposes, that is called spring force. Opposite direction to its displacement. Displacement, it's increasing. Force is what? In a opposite direction. Okay, so here is what is, it's a spring force is like this. So this is what external force is like this. This is what it's a spring force. It's a spring force. Okay, these are in opposite direction, right? So spring force is equals to F spring is equals to what is this? Minus kx. A force is developed in the spring when small elongation or compression. Okay, when the spring is a little elongated or compressed linearly, such developed force is called what you say? It's a spring force. So spring force is equals to minus kx. X is what? Either elongation or compression. Okay, it's a elongation, otherwise it's a compression. Yes, spring force is for the ideal spring, spring force in the spring is what? Everywhere it is what? Constant. If it is ideal. Okay. Next one, spring force. So, just about spring force means, first for example, I'm talking about what is this? Spring, okay, force. Spring force is what? It's a the force developed in the spring. Force developed in the spring. Okay. So developed in the spring, opposite direction to the external force, or opposite direction to its elongation or compression. Okay. So when elongation or compression, so compression is occurred. Yes, so compressed, like it's a compressed, elongated. Okay, elongation or compression is taking place. Yes, so in the spring force here, F is equals to minus kx. K is what? It says Spring's constant. K is called Spring's constant. It's a Spring's constant. Spring's constant. Spring's constant is also called stiffness of the spring. Stiffness of spring. Stiffness of the spring. Okay. So this, we have drawn earlier the graph for this. This is what? It's a force. It's what? Elongation. The graph is what? Like this. It's what you say. This is here. You can take in either sides. Yes, it's a, so x. Okay, this is force, maximum force. F is equals to what is it? F is equals to minus kx. Okay, so this is what slope of this. What is this angle? Theta. So F is equals to minus kx. F means what? Here m into a plus kx is equals to 0. M is what? Linearly m into d square x by dt square. M into d square x by dt square plus k into what? X is equals to what? 0. Okay, you can observe this one. It's a differential form of SHM. Differential form of SHM. So K is what? It's a m omega square. Correct? K is equals to m omega square. So m omega square is equals to K. Omega square is equals to, what is this? K by m. Omega is equals to under root of k by m. This is what? Angular frequency. Angular velocity. Omega is equals to under root of k by m. Yes, K stands for what? Stiffness of the spring. M stands for what? Mass of the suspended body, not mass of the spring. Mass of the spring is what? It's a neglected comparatively with the mass of the body. So omega is equals to under root of k by m. So omega means what? It's a 2 pi by t. 2 pi by t is equals to under root of k by m. Then t by 2 pi is equals to, we can say, under root of m by k. T is equals to, we can write what? 2 pi under root of m by k. The time period in the spring. The time period in the spring t is equals to 2 pi under root of m by k. Yes. So it means when a spring is, this is what? Linearly oscillating spring. Okay. It's what? Here it is given. Its mass is m. Spring's constant is k. Spring's force Fs. its weight is what? mg. So this initially it is at the mean position. Yes, it is pulled down to this position. So again it moves back. Its x is equals to 0, x is equals to a, x is equals to what? Minus a. This is called amplitude. The displacement along with this displacement, if I say it's a y naught. Okay, so it's what? The displacement, maximum displacement from the mean position gives what? It's a, what is this? Amplitude. So from this we proved just now, what is this? T is equals to 2 pi under root of m by k. T is equals to 2 pi under root of m by k. M stands for what? Mass of the suspended body. K is what? Spring's constant. So next one, if mass of the spring, if mass of spring is considered, if the mass of the spring is considered, okay, mass of the spring is considered. When mass of the spring is considered, for example, let it be mass of the spring is small letter m, attached mass is capital letter M. Okay, so let, for example, this is what a spring is given. Okay, now attached mass is this suspended mass. It's a capital letter M. This is small letter m. It's a spring's constant is K. Spring force is Fs. Weight is what? mg. Correct? Okay. So then you can write about T is equals to 2 pi under root of, so total mass, this is what? Total mass by what? It's a K. What is the condition? T equal to 2 pi under root of m by K. Total mass is mass of the body and spring. So experimentally, when you take this spring is elongated, 1/3 part of this has maximum elongation. 1/3 part, okay? 1/3 part has its a maximum elongation. It means for the remembering, for the problem solving, 2 pi under root of, okay? So this is what? Capital letter M, mass of the suspended body, and the mass of this one is what? It's a m by 3, yes, by k is the situation. For the mass of suspended body, this is what? Capital letter M is the mass of suspended body. Small letter m is what? Mass of the spring. Okay, mass of the spring. So T is equals to 2 pi under root of capital M plus small m by k into what? So capital M plus small m by 3 by k is the case. This is about just spring at a mass is attached to the spring. Okay? Spring mass system. In the spring mass system, for the spring mass system, the first thing I can show you that T is equals to 2 pi under root of m by k. Is there acceleration due to gravity? Is there small g anywhere? No. Okay. Then what is it? This is what it is. Time period is, T is what? It's a time period. Time period is independent of small letter g. If you do this time period for the spring mass system, you keep it on certain height on the mountains on another planet. It is independent of g. So everywhere then T is equals to what is a 2 pi under root of m by k. That's what we can measure. For accurate measurement of time period, we use spring mass system only because independent of g. So that's what, this is the reason spring mass system is used. It's used for accurate measurement of capital letter T, time period. Okay, it is independent of G. Second, this is what the first thing, and second one I am making as this. If I use the time period, this is the spring mass system is given. It's what? Some mass is capital letter M, which is ideal spring, and it's a, this is what, it's a F is equals to K spring. Okay, so directly I'm writing, it's what, mg. Next one, if I make it as this, some inclined plane is taken. Inclined plane is a fixed position. Some spring is, okay, it's what, making oscillation. This is what, Fs. It makes an angle theta on the inclined plane. Okay, so next one, if you pick, this is what, another case I'm taking as, here is the fixed position. This is what, spring, and its mass is what, capital letter M. It's a F is, this is what, spring's constant K, is making oscillation from its mean position. This is making oscillation from its mean position. It's okay, like this. So this is also from its mean position, it's making the oscillations like this. From its mean position, it's making the oscillations. When it is making the oscillations from its mean position in a different situations, one is vertically suspended. Next one is what, which is there on the inclined plane. Next one is what, horizontal. The time period does not change. It remains constant. There is no dependence on G. So I can say you this is T is equals to 2 pi under root of M by K. Its time period T is equals to 2 pi under root of M by K. So same as T is equals to what you say, 2 pi under root of M by K. Okay, so and it is independent of this. So in a different situations, when it is suspended and when it is placed oscillating on an inclined plane, so then we can say as it's a the time period is what, same. Next, what is the concept of reduced mass? Reduced mass we use. Okay, so then when you're talking about this, it's a reduced mass. For the reduced mass, generally we denote as it's a mu. Okay, reduced mass. We'll discuss later its proofs. But reduced mass is what? Here, whenever two masses are connected. When two masses are connected, reduced mass we use in the moment of inertia. When a rod is taken, two blocks are, two M1 and M2 are connected, it's rotating with respect to one vertical axis. Here is also, that's what, reduced mass, just we can say as, this is what, mu is equals to M1 M2 by M1 plus M2 is the concept of what you say, it's a reduced mass system. Now onwards, anywhere for the problem solving, reduced mass mu is equals to what you say, M1 M2 by M1 plus M2. Okay, sir, till now how many masses were connected for the spring? Only one, which is making the oscillations. See, I'm choosing about this is a horizontal surface. Yes, here two masses are kept here. This is what, its mass is M1. Okay, next mass is what, it's a M2. So these are connected by a spring. It's a spring's constant is K. How many springs do you have? There is only one spring. How many masses do you have? Two masses. So I'm applying the force on this one. Reduced mass comes into play. Its time period T is equals to, we can say, 2 pi under root of mu by K. Mu stands for what? Reduced mass. Okay, so this is what it's a reduced mass. It's a reduced mass. Then T is equals to, we can say as 2 pi under root of M1 M2 by M1 plus M2. Okay, by it's a K. Is what? T is equals to 2 pi under root of M1 M2 by M1 plus M2 by K. Is what you say, it's a reduced mass. So for example, M1 and M2 both are the same masses are there. M and M. What do you say? M into M by M plus M. M square by 2M. MM cancel. What is this? M by 2. Yes, m by 2. What would be its time period? T is equals to 2 pi under root of, so m by 2k. Okay, sir, I know the time period. How can you find its frequency? How can you find its frequency? The frequency is what? Reciprocal of time period. So frequency, if you want to write, just for your kind information, f is equals to what you say, it's a 1 by t. The question is, I have two situations I am giving us. If a body, one body is here, this is the spring, okay, it is, some mass is suspended, spring's constant is what? It's a k. Let it be as given as time period is 4 seconds. Carefully observe this. A spring mass system as given, okay, so some mass is m, right, and it is making the oscillations, from its mean position. Yes, its time period is 4 seconds. If the same spring is given, yes, for this some extra mass is added, okay, so m plus 4 kg mass is added, time period is 2 seconds. What is the mass? What is the mass? What is the original mass? A body of mass m attached to a spring which is oscillating with a time period is what? 4 seconds. So if the mass of the body is increased by how many seconds? How many kgs? 4 kg. The time period increases. Okay. So the time period increases. Time period should be increased. So time period increases by, time period increases by 2 seconds. But by 2 seconds, by means what? Added to first one. 2 means what? Only the value to be given. Increases by 2 seconds means what should I write here? So this is, here I am taking as, what is the initial one? What is the initial one? 4 plus 2. What is the answer? 6 seconds. What is the mass? This is the situation. Now let us see how to solve this question. T is equals to, what is the formula? 2 pi under root of m by k. What is T? 4 is equals to 2 pi under root of m by k. Is my first condition. Yes. Next one. For this, 6 is equals to 2 pi under root of, what is this? M plus 4 by k is my second condition. From equation 1 by 2 or 2 by 1, anyone you can do this one. Yes. So equation number 2 by 1 I am doing this. 2 is what? 6 by 4 is equals to 2 pi the root of m plus 4 by k by 2 pi square root of m by k. Correct? K and k cancel. 2 pi cancels. Then what do you say? 2, 2s are 2, 3s are. Squaring on both sides. 9 by 4 is equals m plus 4 by m. So just you can go for cross multiplication. 9m is equals to 4m plus 16. Yes, it's a 5m transposing here. 5m is equals to what? 16. M is equals to 16 by 5. 5 1s are 5, 3s are 2. This is what? What is the original mass? 3.2 kg. It's a 3.2 kg. So it's a 3.2 kg. This is a question based on this. What do you say? It's a, so time period of spring mass system. And next one here, just I'm writing a question on this. Two springs of springs constants springs constants, two springs of springs constants K1 and K2. K1 is equals to 1500 Newton per meter. K2 is equals to 3000 Newton per meter. K1 and next one is about K2 are stretched by same force, are stretched by same force. Find the ratio of what is this? U1 and U2. U1 and U2. U1 is what? Potential energies. Okay. Half K x square. Careful on this. Spring force is what? First you need to remember about this before solving the question. F is equals to constant. F is equals to constant. F should be fixed in the expression. Means what? U is equals to half K x square. Do you have F in this expression? No. Then what? I should get it that. What is this? F is equals to what? Kx, na? Yes, minus Kx. X is equals to what? Minus F by what it say? K. U is equals to half K. X means what? Minus F by K whole square. U is equals to half K into F square by what? K square. So U is equals to half, okay, F square by what? K. Are these two directly proportional or inversely proportional? Inversely proportional. Okay, so then what? U is equals to, U is proportional to 1 by K. So it's what? U1 by U2 is equals to K2 by K1. So what is the K2 now? It's a 3000 by, this is what? 1500. What is the answer? 2 by 1. It's a 2:1. So earlier discussion what? Just U is equals to half K x square, U proportional to K, U1 by U2 is equals to K1 by K2. You are getting about this 1 by 2, which is wrong answer. Why? Sir, force is constant. Force is constant means what? I should mention the force in the expression. Yes. F is constant. Okay. So next. I'm asking, in a spring mass system, spring mass system, okay, so here I'm giving that some mass is what? 0.998 kg, and so mass is given, suspended mass 0.98 kg. Means what the value? This is what in terms of 0.98 kg. And force constant is 4.84 Newton per meter. Find angular frequency. Find angular frequency. What is angular frequency? Omega. Find angular frequency. What's the formula for omega? K is equals to what? M omega square. Correct na? So then what? K is equals to M omega square. First one is about K is equals to, our basic condition is what? K is equals to M omega square. Then omega square is equals to what? K by M. Omega is equals to what you say? Under root of K by M. Okay. Omega is equals to under root of, what is the K? 4.84 by what? 0.98. Square root of 484 by what? 98. Approximately 2.2. Check it. Square root of 484 by 98, 2.2. Omega is angular frequency. How do we, what are the units? Radian per second. Check the answer. Like the time period of spring mass system T is equals to 2 pi under root of what is that? M by K. Okay. So next one. So this is a condition just which we have been discussing about from this beginning of the session. First one is about time period T is equals to what? 2 pi under root of M by K. That's it. Time period of spring mass system. Only one single concept. The formula is what? T is equals to 2 pi under root of M by K. So next one, where it is independence, where it is dependence, and on what factors it depends. And next one, how do you find the time period and frequency? Next one is what? Angular velocity like. Next, the question will be asking on this. Combination of springs. How the springs are connected? First one is what? Series. Next one is what? Parallel. Okay. Next, the most important thing is about it's what? Very important the concept is what? Combination of springs. Combination of springs. Okay. So in the combination of springs, first when I'm talking about this, it's a series combination. So your series combination. Only one thing we need to remember in the series and parallel combination of the springs. My series combination, first just I'm talking about, sir, one is possibility, two springs, one spring is like this, next spring is like this, connected to the mass, its mass is M. A different material, different springs constants. So let it be its springs constant is K1 and a K2. This is what? Vertically, that's what is it's a freely hanging part. Is okay. So next one, vertically oscillating like. So for example, next one is, this is what? Here one spring, next one is another spring. Here its mass is M. Its a springs constant is K1 and K2. So in series combination, same restoring force exerts in all the springs, but what do you say? Extension will be different. What is the condition in the series combination? Restoring force is same in all the springs. How many you connect? Sorry, n number of you are connecting. That's what restoring force is same. What is the concept of restoring force? F is equals to minus kx. So same restoring force, but elongation you can see different springs. Na? Its elongation it may be x1, its elongation may be x2. Next one is what? x3. Total elongation will be what? x1 plus x2 plus x3. See, restoring force is same, and but what do you say? But elongation is differ. So different for of all the springs. Elongation is different for all the springs. So now we can talk about which is same. Force is same. So which is different? Elongation is different. Force is same means what? Fs is equals to minus kx is equals to what do you say? Constant. Elongation is different. What is the elongation? That's what you say ma? x1. Next one is what? x2. X total elongation is equals to total elongation. E is equals to what do you say? E1 plus E2. That's what? X is equals to what do you say? X1 plus X2. What is the formula for spring force? I just now in the problem I discussed it. Which is constant? That constant term should be in the expression. So what is the condition? F is equals to minus kx. Which is constant? F is constant. X is different for different springs. So now I can talk on this is what? From this condition, X means what? F by K minus. Yeah, F by K1. It's also minus. Next one, minus F by K2. Correct, na? Isn't it? So, X in place of X, what should I write? From this, X is equals to, we can write it as minus F by K, correct? X is equals to minus F by K. Okay. So then X is equals to minus F by K equal to minus F by K1 minus F by K2. Means what? 1 by K is equals to 1 by K1 plus 1 by K2. What is the equivalent springs constant? What's the meaning of equivalent springs constant? Two springs are connected. Just to imagine, 2 become as a 1. 2 become as 1. Okay. This I'm taking as 2 become as like this one. Its mass is m. What is its total elongation? x1 plus x2. Correct? That x1 plus x2 is what? X only. And what is the total equivalent? That is, what is this? Stiffness. Means springs constant. What is this? K equivalent. This is what? F is equals to minus kx minus k1 x1. F equal to minus k2 x2. F is equals to minus k times of x1 plus x2. So finally you got it as 1 by k is equals to 1 by k1 plus 1 by k2. Then k is equals to, what is the condition? K1 k2 by k1 plus k2. This is called equivalent springs constant. So equivalent springs constant is what you say in the series combination K is equals to K1 plus K2. K is equals to K1 K2 by K1 plus K2. Here in the series combination, just K in the series means what? Ks I am taking. Ks is equals to, what do you write? K1 K2 by K1 plus K2. K is equals to K1 K2 by K1 plus K2. Sir, you have just we discussed what? First spring is, next spring this. Its mass is m. It's a K1. This is K1. This is what? K2. This will be what? It's a, so equivalent. Equivalent is what? 2 become as 1 like. It's a K series. And next one is what? Its elongation x1. This is what? X2. This will be what? X. X means what? X1 plus X2. So what is the time period of this? How do we get the time period of this? Time period t is equals to 2 pi under root of m by k s. Correct? So this will be t is equals to 2 pi under root of m by ks. Ks is what? K1 K2 by K1 plus K2 is the concept of series combination. For the series combination of the springs, okay, so I can say you this is what? Ks is equals to K1 K2 by K1 plus K2. Okay, is t time period. If I give you the time period, what about the frequency? If you want to find the time, its frequency is equals to what? So f is equals to what is the condition? 1 by 2. Okay, this is concept of series combination. So let us talk about parallel combination of springs. Parallel combination. Parallel combination of springs. In series combination, what are the keywords? The keywords are same restoring force applied to the all springs which are connected in a series. But elongation is different. In this parallel combination, I'll give the best example for this. You can see this. I'm taking as two springs. Yes, two springs. Its mass is capital letter M. Springs constant is K1 and K2. Same elongation. Same elongation, but different. What differ? Springs force. Different springs force. Okay, so I'll take the situations for like you can say the spring displacement of this combination is what? Same, but restoring force is what? Differ. Okay, so the key words are what? Displacement of combination is same. Displacement of combination is same, but restoring force is what? Different. Is different. But restoring force is different means, first one, what's your condition? F is equals to what's the formula? Minus kx. Restoring force is different. Fs, F1. This is what? F2. What about the displacement? X only na? So just you imagine, this became as a single one. While combining these two, one, that is called equivalent spring. Equivalent spring has some stiffness. That is what? Equivalent springs constant. Means like, okay, yes. Its elongation is what? X only. Displacement is what? X. Springs constant is what? Kp. Forces are what? Differ. Then I can say you this is what? Total force. This is what is the restoring force? F. F is equals to what you say? Minus kx. I can say you this. F is equals to F1 plus F2 minus kx is equals to minus k1, correct na? Minus k1 x minus k2 x. X is same, correct? Then what? K is equals to what you say? K1 plus k2. This is what? Parallel combination. Parallel combination of springs. In the parallel combination, so if I say this, here is the mass like this. It's a K1 and K2. Are these two in series or parallel? Looks like series, but it is parallel because different forces are there. Correct na? Yes, it's a F1 and F2. When they are connected 1 to 1, F is constant. But differently connected, F is differ. F differ means what you say? F is equals to F1 plus F2. Ks is equals to, Kp is equals to what? K1 plus K2. Kp is equals to, we can talk about this, it's a K1 plus K2. Sir, one more. This is the fixed position here. Now say, it's a K1 and K2. Series or parallel? Parallel. Okay? Same the thing. What is this? Kp is equals to K1 plus K2. Kp is equals to K1 plus K2. Finally, what is the time period of the system? Either this or this or this, whatever that. All are same. Connected in what? Parallel. Then what? T is equals to, what is the condition? 2 pi under root of m by kp. It means what? 2 pi square root of m by, what is the k? K1 plus K2. This is very important relation we can talk on this. Here is the situation. This is time period t is equals to 2 pi and the root of m by k. So for the combination of the springs, when they are connected in the parallel combination, k equivalent is equals to kp is equals to k1 plus k2. Connected in series combination, what do you say? So k1 k2 by k1 plus k2. T is equals to 2 pi under root of m by kp means what? It's a k1 plus k2. So here are the questions. Some few models I'm giving that. First one, infinite springs of force constants. Means what? Many springs. Only two springs are connected in series. Means what? They can be connected in series. Series K equivalent is what? K1, K2 by K1 plus K2. In the series combination, what to be remember? What constant? Force is constant. Displacement differ. X is equals to x1 plus x2. In parallel combination, so K equivalent, in series combination K equivalent, Ks equal to K1 K2 by K1 plus K2. For better understanding, 1 by Ks is equals to 1 by K1 plus 1 by K2 plus 1 by K3 plus so on, n. Okay. In parallel combination, Kp is equals to K1 plus K2 plus K3 plus so on, like we can use it. So, infinite, this is the first model of question from this. So, just you can check it as this. Yeah, infinite springs of force constants. These are the force constants. Okay, so force constant, it's what you say, it's a k is equals to k, 2k, 4k, 8k, so on. They are connected in series. I'm asking equivalent springs constant, force constant. Force constant means what? Springs constant only, no? Stiffness only, no? So, we need to write the form. 1 by Ks is equals 1 by K1 plus 1 by K2 plus 1 by K3 plus so on. Okay. So, this is equals to 1 by Ks is equals 1 by, what is the K1? K plus 1 by 2k plus 1 by 4k plus 1 by 8k plus so on. This is 1 by k is common, 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus so on. It's in the form of GP. This is what 1 by k is equals 1 plus, okay, 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus this. Sum of infinite terms in GP. Sum of infinite terms in GP. What's the condition? S infinity is equals to A by 1 minus R. Sum of infinite terms S infinity is equals to A by 1 minus R. Now, this is A, first term. Always you remember. R, it's a ratio of what? T2 by T1, second term by first term. What is the first term? First term is what? A is equals to 1. And T2, ratio R is equals to T2 by T1, 1 by 2 by 1. What is the answer? 1 by 2. Correct? Now, S infinity is equals to A by 1 minus R. A is what? 1 by 1 minus 1 by 2. 1 minus 1 by 2 is 1 by 2. Reciprocal of 1 by 2 is what it say? 2. What's your answer? So it's a 2 by k. What is asking? Calculate effective force constant. This is 1 by Ks. While doing this one, most of us will get the confusion. This is what reciprocal form. 1 by Ks is equals to 1 by K1 plus 1 by K2 plus so on. 1 by K equivalent. 1 by K equivalent. So 1 by K equivalent is equals to. So 1 by K effective is equals to, it's a 2 by K. First one, spring is here. This same mass, it's a M. Spring's constant is K1. Next, another spring is taken. Okay, same mass. Spring's constant is K2. Its time period is T1. Its time period is T2. When these two springs are connected in series combination, with the same mass, in the same mass, okay, so the time period T is equals to what is very important question. Got my question? First one, a spring is taken, its spring's constant is K1. Next spring is what? Spring's constant is what? K2. When K1 is there, its mass M, time period is what? T1. Its time period is what? T2. When these two are connected in series combination, when springs are connected, when springs are connected in a series, in series combination, in series combination, okay, so time period is equals to what? I may also ask the question, if they are connected in parallel combination, what is the spring's constant? Sorry, what is the time period? If they are connected in parallel combination, what is the time period? How do you make this? First one, the basic information for here, just I am talking on this. Our time period formula is what? T is equals to 2 pi under root of M by K. Now what? How these two are connected? In series or parallel? Series. What is the formula? 1 by K is equals to 1 by K1 plus 1 by K2. So this T square is equals to 4 pi square times M by K, correct? 1 by K is proportional to T square. Do you agree with this? Yes or no? How these two are connected in series? Series means what is the condition? 1 by K S is equals to 1 by K1 plus 1 by K2. 1 by Ks. Okay? 1 by Ks. Ks means, how do you go for this? Okay? So T square is equals to T1 square plus T2 square. T is equals to square root of T1 square plus T2 square. Correct na? Is the case. Such a very important relation. Direct question you have. You have a direct question. That's what. Sir, one spring is taken. The spring, a mass of M is connected. Spring's constant is K1. Time period is T1. Next one, same mass is connected. Time period is T2. When they are connected in series combination, so what is the effective time period? T is equals to under root of T1 square plus T2 square. Now you answer my question. If they are connected, when they are connected in a parallel, good, it's what? Parallel. Parallel means what the condition? K. So this is what? 1 by K proportional to T square. Is it okay, beta? K proportional to what? 1 by T square. And when they are connected in parallel, what is the spring's constant? Effective spring's constant. K is equals to K1 plus K2. Correct? K is what? 1 by T square, 1 by T1 square, 1 by T2 square. Then what? T square is equals to T1 square plus T2 square. Right? Means what? 1 by T square equal to 1 by T square. LCM is what? T1 square, T2 square. T1 square plus T2 square by T1 square, T2 square. Okay? So then, how do you write? 1 by T square is equals. LCM is what? T1 square, T2 square. T2 square plus T1 square. Correct? Then T is equals to what? 1 by T. T square is equals to what? Reciprocal. T is equals to what? Whole to the power of 1 by 2 times. T1 square, T2 square by what? T1 square plus T2 square is the case. Such a very important relation. He may also sometimes will be given. At T1 square, T2 square root, what happened? T1, T2 only, no? Isn't it? So T1, T2 by under root of T1, T2 by T is equals T1, T2 by square root of T1 square plus T2 square. Also we can write it. T1, T2 by, so square root of T1 square plus T2 square. When they are connected in a series means what? You got it the point already this. So I'm giving a situation. Next one, this is, there are the two springs. Okay, so these are connected like some mass is connected to this. It's what? K1. Next one is K2. Let it be, some values will be mentioned. It's what? K1, K2. Just you take it as, this is K2. This is what I'm taking as K1. It's a K1. What is the effective springs constant? What is the effective time period? What is the effective frequency? Anyone would be asking. K effective is equals to K equivalent is equals to K equivalent is equals to what? Or time period T is equals to what? Is my question. How these two are connected? Parallel. Yes, na? Parallel. So this would be what? Here. Correct? Next. It's a mass is M. It's a K2. This is what? Parallel means what is the condition? K1 plus K2. How? What is the effective springs constant? Ah, 1 by 2K1 plus 1 by K2 is my answer. Correct? Sir, time period. You can find time period 2 pi under root of M by K equivalent. Whatever equivalent springs constant you are getting, that would be substituted in this. Two springs are connected. It's a K, 2K. Some mass is connected M. What is the time period? So what is the K equivalent? K equivalent is equals to K1 plus K2 because they are in a parallel. They are in parallel combination. K equivalent is equals to K1 plus K2 means what? K plus 2K. What is the answer? 3K. It's a K equivalent. What is the time period? T. T is equals to what? 2 pi under root of M by K equivalent. T is equals to 2 pi under root of M by K equivalent is what? 3K. Is okay? So these are the models, ma.